Hello everyone, I'm Yusuf Erdem Nacar.
And I am Mehmet Emre Akbulut.
We are here to present you our graduation project called Social Network Analysis on Research, or SONAR for short, and we will start with a brief introduction. So what is social network analysis? Social network analysis is the process of analyzing social networks using graph theory methods. What we are trying to do is to design and develop a social network analysis tool to help researchers analyze research network consisting of authors and articles. Why we are trying to do this is to gain insight into the relationships between authors and articles in a given research field. Now, Emre will go over the design of our project.
Our project Sonar is divided into three main components called search engine, graph engine, and analysis engine. In search engine, we allow users to search and select articles for graph creation. Graph engine is mainly responsible for creating actual graphs using the articles selected using a search engine. Analysis engine performs the actions related to calculations of metrics of a graph built using the graph engine. These metrics are between centrality, eigenvalue centrality, page rank, and so on. Our architecture consists of these engines as different Django applications, Semantic Scholar Academic Graph API as external data source, PostgreSQL server, and Neo4j server for keeping the graphs. Our graph uh, consists of articles and authors notes, citation, authorship, and co-authorship edges. Here is the authorship age, here is the citation age, and here is the co-authorship age derived from the authorship ages going to the same article. And here we will show the results of the project.
Now we will discuss our results. Since our aim was to create a tool for social network analysis on research graphs, the tool itself is actually our result. We created a tool that allows the users to list articles related to a specific keyword, select and create a set of articles from these search results, enhance and populate these set of articles using certain actions such as adding all the articles that cite these articles, create graphs from these selected set of articles, and analyze these graphs using graph theory. Now we will present an example graph consisting of approximately 500 articles in the field of click chemistry. And this is the whole graph consisting of author and article notes and relationships between them. And what we can do, for example, is we can run the Lewin community detection algorithm on this graph. But in order to do so, we need to use this subgraph consisting of only the authors and the co-authorship edges between them. And here is the subgraph that consists of only the authors and the co-authorship edges. And after running the Lewin algorithm, we can show you the 8 most populated communities using this subgraph where the nodes are colored by the community index and sized by their degree. What we can also do is we can calculate the between the centrality of each node using the whole graph. And we can see that Calberry sharpless has the highest between the centrality score. And we can also visualize this by using the 8 most populated community subgraph, where the nodes are sized and colored by their between the centrality score. And we can see that Calvary sharpless has the biggest node. And yeah, and although the indirect implications and meaning of these scores are not clear at first, we can be sure that the nodes with the highest scores are clearly interesting people in their research field and deserve closer attention. And it is also worth noting that Carl Sharpless is a 2 times Nobel laureate in chemistry and was recently awarded the Nobel Prize for Chemistry in 2022 for his efforts in click chemistry. Now, we will discuss future work, uh, and what we will do next semester is we will implement a user-friendly UI, and we will try to present these analysis results in a more meaningful and insightful way. And we will also work on the optimization of this application, especially of the parts of the graph building part, and do more research about certain specific research fields such as coronavirus. And we will now discuss the similar applications. There are many applications where you can build graphs from articles or authors, but all of them are focused on providing their users with an enhanced way of doing literature research. So what this means is that they do not provide graph theory measures about these graphs, and they only focus on discovering new articles, discovering new authors, and so on. Our difference is that we allow our users to calculate and obtain quantitative information about the research graphs that they built. Yeah, that's it. Thank you for listening our presentation. Yeah, and see you.